gang, here we go. We are going to move into our next topic called mapping for Geology 1401. And basically what we're going to do is start out with some vocabulary and get you all ready to make your own maps. But later on, we will transition into being able to interpret and read maps that are already made. But for now, we'll just kind of get you started with some basics. And so the first thing is called a field or mapping fields. If you go outside and you can measure something and you come away with a number, that's called a field. So this is a value. So basically it's a number and you spread it over an area. Look at how great my handwriting is. And this is called a field. And we would have gone through all this together in class and you would have been able to fill this out live, but here we are. So field maps or contour maps show a scaled portion of an area, and scaled is an important word, which we'll get to in a minute, and that's of an area again. And so what we do is we put all these field values on the map, and then we connect those values, not values, points of equal value. Okay, so we got a whole bunch of different points and we try to connect points of equal value. And so these are called contour lines, or we also can call them ISO lines. And ISO means same. So the line that you draw is going to be showing the same value all the way along it. So the next thing is a contour interval, and this is the difference in value again between any two lines that are near each other. So what do I mean by that? Well, we're going to take a look at this little map over here on the left and basically find two lines that are close to each other, like consecutive, and then you count, well, how many units are between each of those lines. And so in this one, you have 40 and 50, so the contour interval would be 10. Now, if you didn't use 40 and 50 and you tried somewhere else on the map, like 50 and 60 in this case, just a little map, you get the same thing. Now, also, I will say there should be units here, whether it's feet, miles, meters, something like that. But in the since we're just learning it, we're not going to have units this time. But in the future, this map actually on the left looks like it could be a temperature map, believe it or not. Okay, so some maps have what we call index contour lines, and these are bold contour lines that are labeled. And that's going to make our maps a little easier to read because you don't have every single contour line labeled. And you'll see when we get into some of our examples later that, man, they get really hard to read if you start having too many numbers and labels. Okay, this one's a little bit mysterious, but if you were walking along the ground, and I'm going to use green here, and you're just walking and suddenly there's like a dip or a hole in the ground, well, we have something on a contour map called hasher marks or hasher lines that actually indicate that. So they're little tick marks that you draw on a normal contour line to represent a depression or dip in the land. And I don't want you to get depressed over that. It's just a kind of a hole in the ground or a crater of some sort. Okay, topographic maps. This is really the focus of what we're going to be doing here. And these are maps of elevation. And that's the primary type of map we'll be looking at. And so if you think back to your own knowledge and what you know from previous science classes that you've taken, elevation is the distance above something very important, sea level. So if you go to the ocean, like in Galveston, that beautiful ocean down there, or somewhere else like Hawaii or Florida, if you let your toes touch the water while you're standing on the beach in the sand, you are at sea level, literally. It's where the ocean hits the land. Now, I know that changes from time to time, but we use the average between high and low tides, so don't worry about that. So on our maps, equal elevations are connected by contour lines. Great writing again. We have little things called benchmarks. Those are elevations that have been surveyed and plotted on a map. And literally a marker or a little plaque, piece of metal, or something on like a stake, is actually put in the ground on the real Earth. So if you were looking at a map of, say, the Colorado Rockies somewhere and there was a hiking trail, you might see benchmarks on that hiking trail, and there's actually a thing in the ground that tells you what the elevation of that benchmark is. And you can see there you have a couple of possible symbols. You might see a little triangle or a little X with the elevation next to it. So those are what you'll see on an actual map. And I mentioned scale earlier. This is huge. This is what we have to do is shrink things down to make them more manageable. So if I handed you a map of Irving that was the size of Irving, that wouldn't be very useful to you. You would probably be very annoyed. So what we do is we take that giant area of land and we shrink it down to something that can fit on your desk or on your table. So we're taking a large value that is, and this is a weird word, shrunk or reduced to fit on a map using a graduated line. So what a graduated line is like a ruler. So I'll just draw a little ruler here, 0 and 1, and you just have these little 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and you break it down, and that's called graduations. So you probably have used a graduated cylinder back when you were in high school. Same sort of thing. All right, moving along, another little vocabulary term is called a spot elevation. And if you have like a hilltop or maybe an intersection, like a roads intersection, sometimes lakes or streams, they'll get something called a spot elevation put there. Now there's nothing actually on the ground or on the water that shows you the elevation in this case, but it is on the map. So they use a plus sign. And so I'll just put plus sign so you know what I'm trying to write there. And it'll have the elevation printed next to it as well. All right, so now that you know all that, we're going to move to this beautiful drawing. And I've made this myself, so it's clearly top quality. And I used something called Paintbrush to do it years and years ago, and I've just stuck with it because it's so pretty. And now I'm going to label all these arrows that show the things I just talked about. So the very obvious first thing, this guy right here up in the upper left, this is called a contour line. And so obviously we're looking at a contour map or a topographic map, and all these lines represent different elevations. I guess the next best thing here would be this bold-faced one down here. This is your index contour line. Uh-oh, can't spell O-U-R. And obviously it's bold and it's labeled. Now, going back to why we use index contour lines, obviously if I had labeled every single one of these little lines with a number, it'll get confusing and you'd see numbers all over the place and it would start to get less useful. So we don't do that. So we only label the index contours. These little guys, I talked about putting little tick marks, H-A-C-H-U-R-E marks. And it's specifically talking about these little fuzzy things there that you see. Those are your hasher marks. And really, as I said earlier, it means a depression or a dip in the land or whatever field you're doing. So in this case, you've got sort of a hole in the ground there. We'll talk about what that looks like later. All right, so I'll get rid of that. Now in the center of that is a little plus sign. This is your spot elevation. But it usually would be labeled, and I didn't label it on purpose because we're going to try and figure it out in a minute. And then over here you have a benchmark. See the little triangle, and that also would be labeled, and I didn't because we're going to try and figure it out. So down below this are some questions about the map, and I'll scroll up and down to kind of go back and forth. And the first one is, what is the contour interval? So earlier I told you, all right, well, we got to pick any two lines that are near each other and the closest to each other consecutively, and you have to figure out what the difference is between those two lines. So, well, how do we do that? I see that we do have index contours that are labeled, so I'm going to use this index contour line, and I'm going to try and figure out how many it goes up or down by between those two lines right there. Now to do that, we're going to use both of these, and we're going to try and figure it out. So what you do is you say, okay, well, what do I have to go up by so that by the time I get from this 100 to that 200, what does each line actually mean? And it has to be obviously correct and perfect. So if you tried tens, I'll erase this little arrow here. If you tried by tens, this one would be 110, 120, 130, 140. This one would be 150. Well, that doesn't work, does it? So don't use it. Try something else. Don't cry about it. It's okay. It's science. We try and we fail and then we learn from it. So now try 20s. So 120, 140, 160, 180. Oh, and we arrive nicely at 200. So that's exactly what we want to do. And we're going to use that as our contour interval. So this little gap right here, this line would be, this one would be 120. So we now know that they go up by 20s. Okay, so put that down here. 20, now we usually put units on these things. And I told you before we were being generic, but now we're talking about elevation. So what do we usually put for elevation? Well, in America, we use feet. On this map though, and you'll see this somewhere on every single contour map, there'll be some sort of indication of what the units are. Now this is meters, so maybe we're in Canada or in Europe or anywhere else in the world because meters are better, but that's just another opinion of mine. So anyway, you would just put a little M after that for meters. Now, the hilltop we're talking about, and I'm going to kind of shade this, let's go with green, is over here. This is your hilltop. So we want to figure out what the highest possible elevation at the top of that is. So here's how we do it. Remember when we just found the contour interval? Well, we're going to try and figure out, okay, if this is 200, this bold-faced one right there, the next one up would be 220. And then the next one up from that, this little guy right there, would be 240. Okay, does that mean that once you get to the top of a hill, it just goes completely flat and everybody's at 240? No, that is not good. What we want to understand is that hills usually look like this on top. So it's natural and has bumps and dips and high points and low points. And you can think about what the Rockies or the Himalayas or something would look like if you're staring at them from the ground. You'd see very irregular tops on them, so not flat at all. So that means that this little triangle could be higher than 240, couldn't it? But how much? What is the maximum possible? Well, start at 240. If there was another contour line surrounding that triangle, so if it looked like you had another one kind of going around, that would be 260. Well, it's not there. So the highest whole number you can reach without hitting 260 would be 259 meters. Okay, so that's how you figure out the maximum possible elevation. It always ends in a 9 because we're going to the highest whole number possible before you actually hit the next contour, or what would be the next contour line. So since there's no 260 in there, the highest we can go is 259. And you can obviously pause and rewind this and listen to that explanation again if you're confused, but we'll be doing it a couple of times in practice. So, all right, I'm gonna get rid of all this fancy stuff here and move down. Steepest side. Okay, if you look at this whole map, what it's asking for is what side of the map or what part of the map is steepest. So in order to figure that out, first of all, you need to know what way is up. What are we doing here? Every map also has a little thing that might look like that, or it might actually be a little bit more fancy. So I'm going to switch and show you what, if it were fancy, it would look something more like this. And we all know what that is, right? That's a compass rose. And so it kind of gives you rough ideas of north, south, east, and west. But we're not fancy. All we get is that little upward arrow that says north, but you can figure it out. So what you would do is kind of look at your map in quadrants. If you just kind of split it into 4 equal pieces, where is it really the steepest? Now, how do you figure that out? Well, you got to kind of look at what do contour lines really mean. And so where does the elevation change the fastest? Well, if you were just walking across this map, if I'm walking around over in this, well, let's use highlighter here, in this general area, it's not really changing all that much as I walk like this. But if you switch this up and you go over here, now if I walk the same amount of space, look at how much my elevation changes. I've hit 100, 120, 140, 160, 180, almost 200 very quickly. That's steep. So we're going to basically call this the, I guess, the eastern half or eastern quarter of the map that's showing us this this steepness. So let's go down and label that. I'm getting rid of all the marks. So we're going to say the east side. And here is the reason. The contour lines, or evidence, the contour lines are closer together in the east. So that means rapid elevation change and steep slopes. So if you were hiking, it would be a harder hike if you were on the east side versus if you were somewhere over here, which really isn't not as steep. So it would be a little more gentle hike. Now, one question that is not on my little list here is, what is this little spot elevation in here? So I'm actually going to make a new question out of nowhere. I'm going to put lowest possible elevation at the plus sign. So there's a plus sign with quotes around it. And so we're going to fill in kind of a question that's not actually there. And I'll switch this to plus signs. So if you're looking back at your notes, you know what we were talking about. So I'm just going to write plus sign there, which is the spot elevation. So let's look at this. Here's what happens. You're walking, let's pretend you're walking from, here's you, you're happy, you're hiking a trail and you're walking towards that spot elevation. What's happening? You're going from, well, we know this is 100, this is 120, 140. You're going up in elevation, but then you hit this area where it suddenly starts to go back down. So you're going kind of up, 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 and then you start to hit this. I forgot this does that now. You're kind of going up and then it goes back down into a dip. So here's the kind of, I mean, it would be much better if we were in class that I could show you this, but here's the general rule. Here's what the elevations will do. You're going to get a repeat. So this is a 120, this is 140, this is 140 again. So you're going to kind of go up and then back down to 140. So you get two in a row, and then it starts going down by 20s. So this one, the little one in there with the little fuzzy things on it, is 120. Now, again, if you look at what a dip looks like, look to the right of your screen. A dip is like this. It doesn't just go down and then it's flat on the bottom. Oh, boy, I got to get used to one of those fancy features on this. It's not just flat on the bottom. So what we have to do is guess how low can it go. So this is illegal. That is not what it's doing. So it goes down a little further, and we got to figure out how much. So again, same as over at the hilltop, what would it be if we had another little black contour line in there that had the little fuzzy things on it? Well, it would be 20 less than 120, which would be 100. But it's not there. So there is no 100 contour line with little fuzzy things on it. So the lowest we can go, whole number, without hitting 100, you guessed it, is 101. So this would be, 101 meters. So again, you can pause and rewind and kind of think about why that might be. But again, it's the reality. If you look over on the right here, we're not hitting 120 feet or meters rather, and flattening out. It's a normal natural contour at the bottom of a hill or inside a crater or something like that. So flat surfaces in real Earth are very unusual. Usually you only get flat surfaces if it's a road or a parking lot or something that we made. Okay, that's all about that beautiful drawing map there. So we've got another little thing, and I'm just gonna kind of go through this quickly for now, because you're going to not like this until you actually see it on a real map. But contour lines, when they cross, so I'm gonna kind of highlight this thing in blue right now. This is a stream. There's the water, it's flowing, it's beautiful. And it says upstream is to the left, which means that this water flows. I'm going to write water flow is that way. So that would be, that's an ugly arrow. I've had too much coffee today. That way. Still very wiggly. Okay. And they, as contour lines, so if you're a contour line, I'm going to switch to black here, and you're just going along, you're going to bend upstream as you cross the river. And all of them are going to do that. So it's going to look something like that. So even as the stream curves over here, they're still going to point upstream, but they will look like the curve does. So I didn't mean to do that, but hey. So that's what's going to happen here. And that happens in every single map that we do. And we'll see that as we go through in the next couple of minutes here. There's a map that we're going to work on together on the next page here. That's water flow. There we go. So they point upstream, and they make a V shape. So you can see all these look like sideways V's, like right there, right there, right there. Those are all V shapes when they cross the stream. Now stream, river, creek, whatever you want to call it, it's all the same thing. Okay, so why that happens, it kind of has to do with if you're, if you're watching a river and what way do rivers flow? Well, if you're a stream, you're going to flow downhill, right? So if this was the land, I'm going to kind of draw a little terrible picture here. Here's your land. If water was flowing on it, the water has to flow downhill. Gravity obviously is working here, so the water is flowing that way. And downhill can be north, south, east, or west, if you think about what a mountain looks like, but it's always going to flow downhill. So here's the deal. These contour lines that we see over here, those are lines for elevation. So I'm going to switch to purple. Here is, let's say that that's 100 meters of elevation right there for that stream. Well, the deal is rivers look like this. So I got to switch back to blue. Here's your, if you're in the water and you're swimming, the actual bottom, and I'll use brown for dirt or mud, looks like this. All this is water right here. But, if you were swimming and you swam all the way to the bottom, let me make another stick figure here, your elevation is lower than it would be if you were floating. So what that means is if you're down here at the bottom, this is what our contour lines actually show is the rock elevation above sea level. We don't care about what the water level above sea level is because it changes all the time. So if I'm at 100 meters and I want to, if I want to go up, if I go upstream, my elevation is going to increase. But these contour lines kind of show that in order to get to, say, 100, let's go with 100 again. I'm going to label this one. Let's pretend this one here is 100 meters. If I'm here on the surface of the water and I'm 100 meters above sea level, that's not what the contour line shows. In order for me to get to 100 meters above sea level with rock underneath my feet, I need to actually travel higher up the hill that this stream is flowing down to get to 100 meters. So it's very complicated. If that doesn't make sense to you, who cares? You don't need to worry about the details of it, other than, I didn't want to do that, other than the contour lines make that V shape. So all this, you don't need to worry about. Just understand that the contour lines are always going to make a V shape that points upstream. And once we see that on maps coming up, you'll actually really kind of, it'll make more sense because you'll see it happen over and over and over again. Okay, so our next thing is going to be, we're going to make a contour map, but I'm going to let us all pause for a minute and we're going to take a little break here. So if you want to kind of stop this video or whatever, I'm actually going to stop making this video and we're going to switch to a new video right after this, just in case I mess up.